Hello everyone, and welcome back to CheMEMEistry.
Yeah, get into it!
We've had a break. Life's gone in the way of my true passion, which is obviously teaching chemistry on YouTube. So we're back. We're going to do a bit of physical chemistry.
Nice.
And we're going to do atomic structure today.
Wig, okay.
So there are three what we call subatomic particles. They're little tiny things. They make up atoms. Atoms, as I'm sure you guys know, are particles that make up every substance.
Whoa.
And they're kind of essential to chemistry. So, to make up our atoms, we have three subatomic particles. We have protons, neutrons, and electrons. And they all have different properties. It means the atom can do its job. So a proton has a positive charge. Now that's kind of an easy association. Proton, pro, positive.
Broom, broom.
An electron has a negative charge. Just kind of think it as the opposite of a proton. A neutron has zero charge, it's neutral, and they sound each other. So proton positive, electron negative, and neutron neutral. And the way we sort of talk about that is a proton has a charge of +1, an electron has a charge of -1, and a neutron has a charge of 0.
Simples.
Because they're not all the same size. A proton and a neutron are the same size. They have a mass of 1. Okay?
Remember.
An electron is much, much smaller. It's tiny. It has a mass of 1/1840. How the flip can I remember that? Well, don't ask me, mate. I don't know.
Wig, okay.
So, whereabouts are all these particles? Well, we have a thing called a nucleus. Now, a nucleus is the centre of the atom, and it consists of protons and neutrons. And around it, floating around, having a party, are the electrons.
You like jazz?
The electrons orbit the nucleus, and they do that because they're attracted. Now, how are they attracted? Electrostatic attraction. Negative always attracts positive. You better learn it, alright? Or
Why you have to be mad?
the nucleus is held together by something called the strong nuclear force. You don't really need to know that. That's more physics.
Who cares?
So we can talk about some properties of any atom based on these subatomic particles. Number one, we've got the atomic number. The atomic number is given the letter Z, because why not?
Why? Why not?
The atomic number is how many protons there are. The atomic number, I think, is the most important number. You'll find it on the periodic table. It's the little bottom number. The number at the top, what's that? That's the mass number. The mass number is basically all of the protons and all of the neutrons added together. You remember that electrons are miniature. They're boring, they're tiny, they're little poo-poo boys. And they really, when we're calculating a mass, don't really matter. The mass number is given the letter A. So we know the mass number, we know the atomic number. And from those two values, you can really work out everything. If it's just a plain atom, the electrons are the same as the protons. We're going to talk about something called an isotope. An isotope is a version of an atom, but it has a different number of neutrons. You know, she's a bit different, but she's quirky. So the mass number changes, the atomic number stays the same. Chemically, she's pretty much the same. They react in a very similar way to all of the other isotopes of that particular element. So carbon-12, carbon-13, carbon-14 are all different isotopes. They all react in the same way. This is because the electrons determine chemical properties. Protons determine what element it is, but the amount of electrons determine how that acts. And yes.
Simples.
I've been CheMEMEistry. Thank you so much for watching.